Right. So when it comes to Java collections, we use Java collections to keep set of data. Right. So we know that we can subdivide data or variables into different categories: simple data, or atomic data, and composite data. So composite means more than one value can be kept. Okay. So to keep simple data or to keep just one value, we can go for either some primitive data types like int, double, float. So if you define something like this, int x equal 10. So that means at a time you can keep only one value. So at different times you can say x equal 12, but just one value at a time. Right? So there are some primitive data types too. All the primitive data types support this simple one value data. Then last time also we discussed there are some object types also. Just one value, like the wrapper classes of these. For example, integer, character, right? So double with D capital. So those are also still simple. We can keep only one value, but those are reference object types. And also string also little bit composite, but as a whole we can consider that chunk as a one. So therefore, if you want, you can consider string also as a simple type, but it has a little bit of composite nature as well. So composite type means one variable you can keep set of data, not just one variable. Okay, so then we call it composite types. So far we have learned one approach of keeping composite data, right? So that is use of arrays, right? Arrays. So for example, if you have int array, say new int 5 or something, so that means now you can keep 5 data, right? 0, 1, 2, 3, 4, right? So that means by just one variable using the index we can refer to different data, right? So today we are going to discuss another approach of composite data, that is collection framework, right? Collection framework. So that is the big picture of the collections in Java. So that is a big picture that what we are going to do. So now we already know the use of arrays to keep to have single variable to keep multiple data. So today we are going to discuss another approach called collections. Again, using one variable we can keep a set of data. Okay, right. So that is the idea behind today's first topic. Right. So when it comes to collections, so now we have once you learn collection, you have two options. Either you can go for arrays, okay, or you can go for collections, right? Collections, right? So once we are done with the collections, so you are going to encounter another composite data structure, okay, right? So why we have collection is there are different requirements where arrays are not good enough. Okay, so for that they came up with the concept called collections. Of course, there are situations arrays are the ideal situation to keep multiple data, but there are some other situations the collections are going to be better suited for your requirement. Okay, so that is why we have another approach called collections. Okay, so basically collection in Java, collection can keep set of data, right? Set of data just like arrays. So it can keep set of data in a single variable, okay, in a single variable. And of course you can then insert, update, delete. If you want to do some other manipulations, those kind of things also can be done, right? In your collection, right? In your collection, it's actually more versatile than arrays. So arrays are there just to keep your data and later retrieve. That's it. But when it comes to collections, they are little bit more versatile. So that means they are little bit more functionality wise, they are more rich, right? So not only you can keep it and take it later, there are some things that you can do with those data, right? So for example, we can ask the collection to keep your data in a sorted order, right? We can ask the collection to keep your data in the order of insertion, right? So then there are different type of collections that will best fit for your different needs, right? For example, we have something called list, we have something called set, we have something called map. So likewise, there are different collections which will best suit for your different requirements. Okay, so that is why we have another concept called collections, but pretty much it will be a sort of a array as well, right? But these things are a little bit more functional wise rich. Okay, right. Right, now let's compare these two. So because otherwise you don't know where when to use collections, when to use arrays. Of course, you can again revisit this once you understand the collections. But at the very beginning also, let's try to figure it out. Where are we going to use collections? So what are the process and cons of arrays and collections? So arrays will be consuming less memory, whereas your collections are going to consume little bit more memory. So therefore that is sort of a disadvantage when it comes to collections. So that means if you are really interested in preserving your memory, sometimes you might decide, okay, I will go for array, right? So then, so arrays are just a simple data structure, just it is there to put your data, right, and take it later. But collections are more they have more variety of data structures, right, and also they have more functionalities as well, right? So there's a variety of data structures like list, set, map, etc. And not only that, they can do certain functionalities as well, right? Another one is, so that is sort of a good point for collection, right? Then arrays are fixed size, especially in Java, right? So when you create an array, you have to give the size, right? You have to give the size. If your array size is 10, there is no way you can insert the 11th element, right? 11th element. So in that case, you have to create another array and copy all these elements and then use your other elements. So therefore, in Java, arrays are fixed size, but collections are dynamic. So that means you don't have to specify the size upfront. Whenever you need, you can keep adding and you can keep removing. So therefore, it's a dynamic data structure. So that is very important if you don't know the size of the data upfront. Okay, upfront. Right. Then there are no direct utility methods for arrays. So because arrays are just there to keep data and take it later. Right? There are no utility methods. There are no direct utility methods. Actually, if you want to do some manipulations, there is another class called array. Right? Array. So you can, so that array class has some methods for doing certain things like sorting, etc. But your array object does not have those functionalities built in. So if you want to do that, you have to go for this utility class called array. But when it comes to collections, they have built-in utility methods, right? Utility functionalities which you inherit when you are creating a, for example, when you are creating a list object, when you are creating a set object, you will inherit certain functionalities to your list or map or whatever. So that is a plus point for your collection again. Okay. So then arrays, the type safety is enforced by class name. So that is why when you are creating array, for example, you have to say what is the data type. Right? So once you create a int array, right, like this, you can't say your x0th element is 10.5 because then it's going to be compiled error. So the type safety is enforced by the class name because you have to give the type, right? Type, data type. But when it comes to collection framework, actually there are two variations. What is known as the use of generics and without use of the generics. So that is why we are going to discuss generics as well today because it's highly related to the collection framework. There, if you are not using generics for those collections, one for example, if you create a list, to that list you can insert anything, like if you can insert 5, you can insert 7.5, you can insert some text like hello. So you can see it's sort of a general thing, so you don't have type safety in that kind of situation. But optionally you can enforce type safety by the concept called generics. it is not by the class name, it is by the concept called generics. If you want to have the type safety, so usually the type safety is a very important feature. So when you want to have that type safety, you are going to use a different concept than your class name or the data type name, something called generics, right? Right. So we are going to discuss generics after the collection framework is done. Okay. Right. So those are the pros and cons. Now you can see that if you just want to keep something and later take it, and you are or else you are really worried about taking memory, go for arrays, right? But if you are not much worried about the memory, right, and also you want some specific functionalities from your data collection, and sometimes you want to do some manipulations, etc., right? So and also if you are not sure of the size upfront, go for collection framework, right? Go for collection framework. Right, now let's see, now let's, because we have already done the arrays at the very when we are doing structured programming, so let's discuss the collection framework. Okay, right, now I hope you have some idea about why we are going to learn this. Right, so when it comes to collections in Java, so it provides three main concepts. So what is known as interfaces, right? What is known as the implementation of those interfaces, and some algorithms. Okay, so the implementation will have some algorithms as well. So what are those features will be defined by the interfaces, right? So another reason why we are doing this after object oriented programming is you need those concepts like polymorphism, inheritance to better or to properly understand the collection frame. Of course you can just get some idea, but what we expect is not just some idea, you are 100% confidence about the concepts, then only you are going to start writing programs in with a lot of confidence. Okay, right, so the interfaces, the implementations, and some algorithms which will be part of the implementation. Okay, right, then all these Java collections are in package called Java util. So therefore, whenever you are going to use Java collections, you have to import the Java util package, or either you have to import everything, like java.util.star, or you have to just import the specific classes and interfaces you are going to use in your uh, class. Okay, so that is very important because the collections are not in the lang package, right? So that if it is in lang package, you don't have to import like the string exceptions, most of the built-in exceptions, etc., but these are in the util package, so therefore you have to import and use it, right? Import and use it, so therefore we are going to import those packages before using any of the collections. Okay, so those are the important things you have to understand, and sometimes you have to memorize as well. Okay, right, now let's see what are the interfaces in the collection framework. Remember, we are going to discuss a few interfaces, right? Interfaces, then some implementations of those interfaces. Right? Right. So now let's see what are the interfaces available. So there are little bit more than little. I have only mentioned few interfaces because it's little bit big framework, right? So let's look at what are the interfaces available, or what are the important interfaces for us, right? For us the important interfaces are the set, right? Set, list, queue, right, and map. Okay, so actually these are the concept we are going to discuss first, then I will explain you the one by one the exact interfaces. Okay, so we are going to see certain concepts, so let's look at the concepts first. The concept called list, right? Concept called list. List mean data, interconnected sort of a data, right? Interconnected sort of a data is called list. So after this we have this, after this we have this, after this we have this, so that kind of a thing is called a list. Okay, then we have another concept called a set. So set is something like a bag, there is no order, right? There is no order, right? But there's another very important feature, that is you can't have same data twice, right? You have already learned those concepts of sets in maths, semester 2 maths. If it is a set, you can't have the same data twice. That means duplicate data is not allowed, and also there is no order, right? If there is no order and the duplicate is not allowed, then we say it's a set, right? It's a set, right? So in the list, there is no such requirement. So duplicates are allowed, right? Duplicates are allowed, and also it's sort of ordered. It's sort of ordered, but here not ordered, and duplicates are also not allowed. Then there's a special case of a list called queue and stack. So basically, stack means last in first out data structure, right? So whatever the data you entered last will be the one that will be taken out by you when you ask you to when you ask it to give you the data. Okay, so that is called a stack. Then we have the queue. So queue is a first in first out data structure. So that means when you insert data, right, 5, 10, 12, etc. Now if you remove, what you are going to get is first 5, then 10, then 12, etc. So that means it's a first in first out data structure, right? First in first out data structure. Then we have another concept called maps. So map is a key value pair, right? Key value pair, right? It's something like this. So we have set of data like this. So we have concept called key and concept called value. Something like Nimal is your key. Maybe his mark is 50, right? Kamal, maybe his mark is 70, right? So in arrays, we found that again we have something called key, or we call it index, but it is always something like 0, 1, 2, 3, etc. We can't have whatever the index that we want, but when it comes to maps, we can have whatever the index we want, right? It can be any data type. So that flexibility is there when it comes to maps. Okay, so sometimes it is convenient to put it into a maps and later take it out, because you can use your key, right? You can use your key rather than having whatever the 0, 1, 2, 3 value, because 0, 1, 2, 3 is sort of a just incremented value. Okay, but here it's more make more sense. What if I want to find the marks of Kamal? I can send the index or the key as Kamal and ask give me the value. Okay, right. So likewise, there are different data structures in the collection framework. Okay, collection framework. So those are heavily used when you are developing a software. So if you are using Java, you will be heavily using these data structures, right? So you will freely pick and choose, pick and use, right? At a time you will go for list, another time you will go for set, another time you will go for maps. Likewise, you will be heavily using those concepts. Okay, just give me 1 minute. Okay, so can you all hear me again, because I just changed my internet connection? Can someone respond? Can you can you hear me again? Because I just reconnect from my other internet connection. Okay, thank you. Right, so we will continue. Right, so likewise now we have more variety for different purposes. Right, different purposes we have more variety called list, set, map, etc. Okay. Right, now we are going to look at it one by one. So when it comes to collection framework, so as I told you, we have two type of things known as the interfaces and their implementations, or the interfaces and classes, right? So you know the difference between interface and class. So interface is just sort of a contract. So it defines what kind of functionalities we can provide you, right? That's it. The implementation is the real classes that provide that functionality, right? So this gives you the contract or the promise. Okay, we are going to implement this. If someone some class says it has implemented this one, so that class is going to give you that those features, because it's a promise that this class has to fulfill. Okay, so that is why there's a rule from in object orientation saying that if a class implements an interface, it has to implement each and every method, otherwise there will be a compiler, because it's a contract. Okay, it's a contract. Right, now let's see the interfaces available in Java collections, right? So the root interface is called the collection interface, right? The collection interface, it's an interface, a built-in interface in Java. Then extending that interface, we have three interfaces called set, list, and queue. Okay, so then there are some sub interfaces like sorted set, navigable set, etc. Okay, we are not much interested about that. We are only interested about set interface, list interface, and the queue interface. And again, we are more interested about the set interface and the list interface, because there are some implementation of set interface like hash set, tree set, etc. And link hash set. There are some implementation of the list interface like array list, vector, linked list, and also there are some implementation of the queue interface, what is known as a priority queue. Okay, so so those are the three important interfaces: set, list, and queue. Okay, so then we have another interface called map, right? That is not extended from the collection interface, so that is called the map interface, right? Map interface. So from that map interface we get something called some implementations called hash table, Hashmap, and also again there are some sub interfaces also. Then we have something called tree map, link hash map, etc. Okay, so don't worry that there are so many things. Don't worry. We will see the connection between those things, right? Once you see the connections, it is not going to be difficult, right? You are going to appreciate the features, right? Only thing is, try to understand this, don't memorize. So if you try to memorize, this is going to be really stressful stuff for you. Okay, right? So we are going to take one by one, but this is the big picture. There are a few interfaces that we are interested, and there are some implementations that we are interested. Okay, right. Right, so we are going to take the first interface now, that is list interface, right? List interface. Okay, so we are going to discuss the list interface and its implementations, then the set interface and its implementation, the queue interface, its implementations, and map interface and its implementation. So there are so many similarities, dissimilarities, connections, etc. Once you understand those things, right, so it's going to be really easy thing for you. Okay, right. Right, now let's look at the list, or the list implementation. So the implementations of the list interface. Okay, so when it comes to list, there are three implementations. Actually, first I want to explain what is mean by list a little bit in detail. So list means, so when we say list, it preserve your insertion order of the data. For example, if you are inserting something like 10, 5, 8, 3, say 15. So if you are inserting it to a list, it will preserve the order. it will preserve the order. That means it knows that after 10 came the 5, then came 8, then came 3, and then came 50. So if it preserves the order of your data entry, or if it is keeping your data in that inserted order, we call it list. We call it list. Okay. So it's a sequence of data that preserve order of data entry, right? And also the duplicates are allowed. So that means you can have again in your list you can have 5. That is perfectly okay, right? That is perfectly okay. It knows that there came a 5 after 10 and again came another 5 after 15. So this 5 and this 5 are two different values for the list interface, for the list. Okay, right? So that is how the list behave. Okay, so it's a set of data, but it preserves the order of insertion, and also it allows the duplicate elements. Okay, right. Now let's see what are the implementation of this particular concept. Right, this particular concept. What is that concept? It's a set of data which preserve the order of insertion, and also duplicates are allowed. Right, so that is how you are how you are going to understand it. Right. So now let's see what are the implementations available in Java for list, the concept called list or the list interface. So we have three implementations, what is known as array list, vector, and linked list. Okay, array list, vector, and linked list. Okay. So then someone will ask why there are three implementations, right? So there are some slight differences between these three. Not the functionality wise, the main functionality wise, of course, all three are list, but little bit of behavioral changes are there. Okay, but so let's forget about these three for the time being. So let's see that let's assume that we have only something called array list implementation, and let's do some coding and try to understand how this list is going to behave. Okay, then we will come back to vectors and linked list. Okay, right. So let's get back to some coding now. Right. So I'm going to create a folder called collections, and I'm going to create a Java class called listdemo.java. So these subjects you can't learn in hurry, right? So that is therefore we are going to do it in little bit slowly now, right? So this is not a theory subject, so you need some patience to understand the things. Okay, let's say class list demo. Let's have main method, public static void main string args. Right. So as I told you, the collection frameworks, all the classes are belonging to the Java util package. Therefore, first I am going to import that, because otherwise I am going to get some compile errors. So I am going to say import java dot util dot star. I am going to import everything so that I don't have to write each and every statement separately. Okay. Right. So then I am going to create a list. So in the list interface, what I am going to use is uh, array list. Okay, array list. So this is how we are going to code it. I'm going to say list, let's say L1 equal new array list. Of course you could have written this as array here, also array list as well, or you can just use the interface here and use the implementation here, right? So use the interface here and use the implementation here. Or the other option is you could have written this as something like this, right? Something like this. Okay, so I won't say that both are the same, but both are going to work. right? So if someone can explain the difference between these two lines, I mean you are really superb person, right? You are really strong in your object oriented programming, right? If you can explain the difference between these two lines, right? uh, Anyone want to give it a chance? What is the difference between this line and this line? So this is my interface. This is the array list is a class which has implemented the list, and here I am using both here array list and array list. Right. So can someone tell me the difference between that? It's something like this. So we have interface called I1. So I have a class called A, which has realized or implemented the A, right? Implemented A. So this one is something like I'm writing. Let's call it I. I equal. So I, let's say I. So this is something like saying I simple I equal new I. And this approach is something like saying A, let's say simple A equal a new A. So what I'm asking is these two the same things or different things, or what is the difference? So can someone at least give it a try? So when you go for if you go for a software developer interview or something, right? So definitely they are going to ask this kind of questions. Right? They are going to ask this kind of questions, right? So if you can answer with confidence, definitely you are in. Right? Definitely you are in. Otherwise, there may be people who can answer these kind of questions, because not only you are doing IT, right? So there are so many people doing IT in different institutes, right? From Morato University to Columbia University, internal students, NSBM, right? So slit everywhere there are IT students. So if you are not as serious as them, so they are going to grab all the opportunities. Okay, so you are not alone, right? You are not alone, right? So the difference is, so when we create this kind of object, of course you are creating a object, right? Because no one gave me the answer. When we say, but we know that A has implemented I, therefore I nature is also there. That I nature is also there, but it's a object. A object. Now if I write this code, it means my reference variable is also of type A. That means it's the entire functionality, right? Because A can look at A. But if you write something like this, right? This must be A. I equal new way. This is A equal new way. If I write something like this, that means of course I am creating a object, and of course it has the I nature, but this reference variable is of type I. Therefore, it can see only I features only. It is not going to see other features other than I nature, right? So I nature. So in this case, we are good at we are usually okay with this one, because we are only interested about the array list nature. List nature. Therefore, writing this is perfectly okay. But this is also not wrong. But this is much more proper professional approach. Okay, so that is something extra just to remind you your object oriented concepts, right? So because I think I kept repeating that your most important topic was the object orientation topic, right? So if you understand that, you are done. So when someone is teaching you, you may feel like, okay, I understand, but when if you can't answer that kind of questions, actually you have not understood it. Okay, so that is also you have to understand that reality also you have to understand. Okay, anyway, I will go for this approach, right? Because anyway both are correct, but this one is much professional approach in object oriented sense. Okay, right? So I'm going to create a list interface reference variable, but actually it's array list. Okay, now let's see how we are going to add data into the list, my list. So my array list called L1. So there's a method called add, right? Add, where you can add your data. Now let's add something like 1. So then you can keep adding. Let's add 2 and let's add 3. Right. Now let's try to print the list and see whether my data is there. So you can just write system dot out dot println and we'll see what is inside L1. Okay, so let's compile and run this. Okay, so it's a very simple thing, but only thing is you must be able to explain each and every line with confidence. Okay, so let's take a command prompt. So let's move on to our folder. Right, so let's compile it. Java C. I will just use star.java because it's going to compile everything. Right, so you can see it is giving me a warning, but that is okay, right? I will explain the why it is giving the warning later because we haven't done the generics yet. But anyway, it could compile. Now let's run it. Okay, now let's run it. Let's see whether the class has been created. Yes. So Java. Now you can see it is printing the collection. I remember I added 1. First I added 1, then I added 2, then I added 3. Now it is printing the collection as 1, 2, 3. So this is how the data is there in my collection right now, right? This is not actually the way it is in the memory, but now you can see it has preserved the order of insertion. So after 1 we have the 2, after that we have the 3. Okay, right? So that is how you insert data into a list object or list instance. Okay, okay. So if you have any questions you can ask, and it's very important for you to ask. It's very important you are asking questions. Okay, I don't know why you are not asking questions, but it's very important to ask questions. Okay, right. Then if you want to remove something, you have a method called remove as well. Let's say from L1 object I want to remove, say I want to remove 2. Now after removing, let's print it again and see whether 2 is still there. Now you can see 2 is no longer there, but still the order is preserved. Now after 1 we have 3. After 1 we have 3. Okay, so that is how it works. Then we have some other utilities, like you can see the size of your uh, current size of the list. That means currently how many data is available. For that we have something called the size method, right? Remember in arrays we had a property called length. In collection we have a behavior called size, right? L1 dot size. So let's look at the size after removing also. So first it has to tell me 3, then it will be telling, okay, my size is now 2. Sorry, I have to compile it again. Right? So earlier it is 3, now it is 3. Now, so you just have to familiar with these basic methods, add method, right? The remove method, the size method, etc. Okay. By the way, in the exams they have not tested much on their collection frameworks, right? Because that is all syllabus. In all syllabus they haven't had much focus on these latter topics, but now they have added so many topics, right? So we have the Java Swing, Java, some other concepts like thread programming, event handling. Therefore, definitely in your paper they are going to ask at least one or two questions on these latter parts. Okay, right? So you can add something, you can remove, you can check the size, etc. Okay, right? Again, we are not going to cover entire collection frameworks, right? We are going to, so these topics we are going to just cover the surface only, right? Because when you need any feature or something, you can just do a Google search and find out whether that particular feature is there. Therefore, we are just going to introduce you the concept only. Okay, right? Now that is what is known as, so that is how the list work. Okay, now as I told you, there are three variations or three implementations of the list. So what is known as uh, the array list, vector or linked list, right? So in this kind of situation, it doesn't matter which one you go for. For example, if I change this to linked list, I am going to get the same implementation, same output. Okay, so I just change it to linked list. Earlier it was array list. Now I'm going to compile it again and run it. So I got the same output, right? Again, if I change it to vector, I'm going to get the same output. So you can see, I can go for linked list, I can go for array list, I can go for vector. For this kind of situation, all are going to behave the same way. So I will just keep it as array list, right? And we found that it preserves the order, and also let's see whether duplicates are also allowed, right? So let's add another 3 here, or another 2 here, or let's add another 1 here. So that means 1 is there in twice, right? No issue, you can see 1 is here, 1 is here, right? Okay, so that is how the list work, where you can add things, you can remove things, you can see what is the size, and also you can see whether particular data is there, right? Whether, for example, you can anytime you can check whether 1 is there, whether 2 is there, right? Likewise, you can check that also. For that you have a method called contains. Okay, contains. So those I'm just explaining you the very important ones only, not for your exam actually. I'm not focusing on the exam right now. These latter topics. I'm more interested about you becoming someone valuable to the society who can do use your things, concepts and develop something, develop software, right? Because we don't care someone who can't develop software, someone who can't work with network, who cares your degree? So for me, I don't care at all. Okay, so actually you are a burden. So let's see whether we can see whether 2 is there, right? So now anyway you can see that 2 is twice there. It's going to say yes, right? So anyway, let's go for something like 3 is there. It's going to say yes. Then we will check whether 5 is there, because definitely 5 is not there. There's no string called 5. For the first one, it's going to say true. For the second one, it's going to say false. Right? So the first one it says true, second one it says false. So those are the functionalities that we want to check, right? We want to check. For example, when you are developing a web application, before giving access to a particular web page or whatever, you want to see whether that particular user has the particular role which is allowed for this particular accessing of this particular thing. So in that case, we will say, okay, my user has a role called, okay, this access is given to the admins only. My user has set of roles like admin, manager, operator. I want to see whether this particular list has this particular role as well. So for that kind of situation, we will just see whether that contains this, right? Likewise, we are going to use these concepts when you are developing the real world softwares. Okay, so there is a life beyond hello world. Okay, there's a life beyond command prompt. right? So we are not going now. We are not using command prompt softwares, right? Sophisticated UI, interaction with other information systems, right? Sophisticated UI, database interaction. So that is the reality. Right? So that is the reality. So that is why we are just learning the concept here, where you must be able to then use those concepts and do some useful thing to your organization or the society or someone who needs some sort of a information system. Okay, right. Right, now let's see what are the real differences between these three concepts: the array list, vector, and linked list. Right. So otherwise, you will get confused why we have three implementations. Right. So those are very technical differences. Very technical differences. Some of those you may not understand also right now. For example, if you take array list and vector, right? Array list and vector, the only difference is array list is thread safe. Sorry, array list is not thread safe, whereas vector is thread safe. Okay, so I gave the same reason when we were doing the string buffer and the string builder. Right, I told you that string builder is not thread safe but faster, whereas string buffer is thread safe but not faster, or it's slower. In most of the cases, I told you that the string builder is going to work. So I am going to tell you the same thing. Array list is not thread safe but little bit faster. Vector is thread safe but little bit slower. Most of the cases, array list is going to work. But if you are worried about multi-threaded programming, so anyway, we are going to do the thread programming is our next topic, right? Then we are going to discuss the UI and finish the your syllabus, like string programming, FX programming. So when you are doing the thread programming, you will better understand this, right? That's because that is what we are going to do next. So array list is not thread safe, but if you are not interested in thread safe thread programming, array list is perfectly okay for you. Okay, but if you are worried about concurrency in thread programming, go for vectors. Right. So that is why you have array list and vector as two classes. So, but in this kind of program, it doesn't matter because we are not doing any thread programming. We didn't see any side effect because both are, but anyway all three are the same functionality. The differences are in some other aspects. Okay, right. So that is the difference between array list and vector. Other than that, array list and vector are pretty much the same. Then the difference between array list or vector compared to linked list, right? Compared to linked list, it's again very subtle, sort of very small differences there. For example, actually those are something to do with the way they have implemented it. So therefore, you don't have to worry too much about this difference, but this one you have to understand, right? Just like the string buffer and string builder. Okay, right. So here in linked list internally, that means the JVM use the concept called double linked list. Anyway, you will be learning what is meant by double linked list when you are doing the data structures and algorithm. So in linked list internally, it's a double linked list. Double linked list. Right? So there are two links from here to here and here to here. But when it comes to array list and the vectors or the linked array list and vectors, they are internally still arrays. Internally still implementation is arrays, but linked list, the internal implementation is a double linked list. Okay, so therefore, I already told you that arrays are a little bit faster, right? Arrays are a little bit faster. So therefore, but what happens is therefore, but when it comes to manipulation, because we have links between these nodes, the manipulation is going to be faster for linked list, right? Faster for linked list. This one is going to be little bit slower, right? Comparatively, right? And also since these links need extra memory, this is going to take more memory. I told you that usually if it is something is array based or closer to the array, it need less memory, right? It need less memory. But when we have so many pointers pointing here and there, it need little more memory, right? More memory. So that is again sort of technical thing, right? if you are not going to manipulate data much, you go for array list or vector. If you feel like okay, we are going to manipulate data much, go for linked list. Okay, so that anyway, I'm pretty sure they are not going to ask this in your paper, but they may ask the difference between the array list and vector. One is thread safe, other one is not thread safe. Okay, right. Right, now we are done with the list interface or the list implementations. Now we are moving to the set. Right, now we are moving to set. So as I told you, the difference between list and set is when it comes to set, first thing, order is not preserved. Now remember, in the list the insertion order was preserved, but in set order is not going to be preserved. So that is the first difference. The second difference is in list duplicates were allowed, in set duplicates are not allowed, and that's it. And also again we have three implementations, but if you take the set nature, all three are the same. Again, just like our linked list versus vector versus the array list, there will be some other technical differences between these three. But as a concept, all three are sets implementations. Okay, right. So now we can go very fast. Now let's just save this because I'm going to do pretty much the same thing with set also. So let's save it as set demo. Set demo. So I'm going to call it set demo. Right. So now I am not going to create a list. I am going to create a set. I am always going for the interface in the left hand side or the reference variable. Right hand side only I am going for the implementation. But it's okay if you go for implementation both sides. Okay. So I am going to use now. Remember how many implementations are there for sets? We have hash set, link hash set, and tree set. Right. So I will go for hash set because that is the simplest one. Okay. Right, now this is a asset. Right, now again, for just like the list, we must be able to insert data to the set, take it, right, and see whether particular thing is there. Okay, so the same thing we can do. We can see whether we can edit using the same method. That right, now we can see. Now we can use the same thing, but the only difference is now it is not going to allow me adding duplicate. Actually, it is not going to give me error. It is going to ignore if I am adding same thing. Right, if I am adding same thing, it is going to just ignore me. I will call this S1, right, because it's a set. And I'm going to just print my set, and also I'm going to see the size of my set as well. So for the time being, let's comment these lines. Right, now let's compile and run it. No errors, those are just warnings. You will understand why these warnings are there when we discuss the generics. Okay, right, so now let's try to run this Java set demo. Right, now we can see that though I have added one again, now in the list one was again there, but now we can see it has ignored my this particular addition of one because one is already there. Right, one is already, so that means this is a set, not a list, right? And let's see whether no, that is duplicate is not allowed, and duplicate is not allowed. And now let's see whether the order is preserved. In this case, of course, you will feel like order is preserved, but that is not a must. Right? That is not a must. There is no guarantee of order is preserved. Sometimes even when you run it again, it may not be preserved, but it can preserve also. But there is no guarantee. Right? There is no guarantee. In this case, you will feel like almost all the time it is preserved. But when it has so many data, it is not going to preserve your order, right? It is not going to preserve your order. Actually, in Java, they are not randomizing. If you go for something like Python, they always randomize also. That means in Python, when you run it twice, most of the time, you will get a different output as well. But in Java, they don't worry about making randomize. But only thing is, you can't rely on Java to keep preserve the same order. Okay, same order, right? So that is something you have to understand. Okay, but anyway, you will feel like the order is preserved. That is because there are only few data here, and also Java because it's overhead to randomize it. Therefore, it will most of the time keep the order of your insertion, right? But there are some languages like Python where they obviously randomize your data. Okay, to make sure that the order is no order is preserved. Okay, right. Now let's see how to remove, and then we'll again print the uh, so we'll now anyway 2 is there. Now we have removed 2, and again we are printing the list. Now it must be S1. We'll print the size as well, because now earlier it says size is 3 because the duplicate one was rejected. It is not an error, right? It is not giving you error, it just ignore. Right? Now we are removing 2. Okay, not L1, it must be S1. Now let's run it. And now you can see I removed 2, and now 2 is no longer there. 2 is no longer there, the size is 2, right? So you can see it's pretty much the same as list. Only thing is duplicates are not allowed. There is no guarantee of order, though you feel like order is preserved. That is just because you have only few data. Okay, so actually JVM doesn't make any attempt to preserve your order. Okay, right. So now I hope you know the difference between list and set. Okay, list and set. Now let's see why we have three implementations. That three different implementations called hash set, link hash set, and tree set. Okay. So I forgot to mention for one thing. Right. So when it's come to link hash set, uh, it try to preserve the order actually, right? And when it comes to hash set, that is one, it is not going to preserve the order. But actually what happens is I use the hash set, right? I use the hash set. You can see still the order is preserved actually there, but the only thing is there is no guarantee, right? There is no guarantee, but still you can see in this case still the order is preserved. But if you want to go for if you want to preserve, if you want to have that guarantee of preserving the order, you must go for link asset. You must go for link asset. So you know that link list is something like connected one, right? Connected one. So therefore, you will learn this when you are doing semester 3, not 3, semester 4. Data structures and algorithms. So in a linked list, they can just remove this and connect these together like this. Then order is always preserved. Right? Order is always preserved when it comes to linked list. Okay. So therefore link hash set will preserve your order. In hash set there is no guarantee, but in our case we found that it is still preserved, but there is no guarantee. Okay. So but when it comes to tree set, it maintains the sorted order, right? So it maintains the sorting order as well, right? So now let's change this tree set and see whether it's sorted, because there are situations we like to have our data in a sorted manner, right? Sorted manner. So now I'm changing this to tree set. In this case, it will be using the alphabetical order, right? So where B is bigger than A, C is bigger than B, etc. Okay. Right, now let's see. Let's compile and run. Now remember, earlier it was the insertion order was preserved, but there was no such guarantee. but now it is not going to case because now you can see T is after O, but here TH is must come before TW because W is after H. When first two characters are the same, it will check for the second characters, right? So now let's see. Now you can see that it is 1, 3, 2. Why? I entered as 1, 2, 3, but because it's a tree set, it is keeping it as a sorted order, right? So because TH is smaller than TW, though the T is the same, this in second character wise H is smaller than W. Therefore, though I added it as 1, 2, 3, it is keeping it as 1, 3, 2, right? So now you can see that if you want to make sure your data is always in sorted order in your set, you can go for tree set. You can go for tree set. But if you don't want that, you can go for if you want to have the insertion order always, you can go for linked list variation of the set. Okay, so that is link hash set. If you don't mind the order, you can go for hash set. Right? But still, all three are set. Therefore, it is not going to keep the duplicate elements. Right? But this is but these two are little bit breaking the concept of set here. They preserve the order as well. But you know that in a set, order is not an important thing, but in implementation they are just uh, they are not worried about change, so they are interested about the order as well. Okay, so here sorting order, sorted order, here the insertion order, right? Insertion order, but here they are not worried about the order at all. Okay, right, now we are done with the sets as well, right? Set as well. Now we are moving to the third concept, the priority queue, right? Priority queue. So you can see that priority queue is a special guy, right? So you can see now set, we have the hash set, link hash set. Now all of a sudden you will feel like this is not a big thing, right? So set is a sub interface of collection. So what are the three implementation we discuss? Hash set, link hash set, tree set. Okay. Then in the list interface, we discuss the array list, vector, and linked list. So what are the differences? This one no order is preserved. This one insertion order is preserved. Whenever you see linked, that means insertion order is preserved. Whenever you see hash, that means order is not preserved. So those are the points you have to remember. When you see hash, no order is preserved. When you see linked, insertion order is preserved. When you see tree, sorted. Sorted. Okay. Actually, you are going to discuss hash data structure, linked list data structure, and tree data structure in your semester for data structures and algorithm subject. Right. So there you will understand these concepts better because you are going to understand how these trees are created, how these trees are maintained when you are doing the data structures and algorithm subject. So in all syllabus it was called programming 2, right? So here if you don't understand these things, of course you might be able to escape your year 1, but you are going to stuck in your year 2, you are going to stuck in your year 3, right? So that is why I am more interested about your long term objectives rather than your semester 1 exam, passing your semester 1 exam. Okay, so some people have that mindset saying, okay, I just want to pass my semester 1, I will be able to do that for my year 2, year 3. No. So those who get excellent result in year 1 will be able to pass your year 2. Right. So that therefore try to get go for the maximum, like A plus here. That means you are good enough to get into your final year and finish your degree. Okay. Right. Right, now we are done with the set and list. Now we are moving to the priority queue. Now you can see priority queue is coming from different interface called queue interface. Right, queue interface. So priority queue has implemented the queue interface. Right, so these are implementing the set interface. These are implementing the list interface. Actually, the linked list is implementing both queue and list, but the priority queue is something implementing the queue interface. And we know what is meant by queue. Queue is a first in, first out data structure. Queue is a first in, first out data structure, but priority queue is somewhat different from normal queue, right? Because if you want for normal queue, you can go for linked list, right? Linked list because it preserves the order of insertion. Right now, you can see if it is preserving the order of insertion, you can go for a linked list, right? So that is why it says it is implementing queue as well, because naturally it is going to be a queue as well. But this guy is a special one. It is called priority queue, right? So it's something like that. So anyway, you are going to learn all those things again in your semester 4, data structures and algorithms. So here, if you get those concepts right upfront, you are in good shape when you go for the year 2. Okay, right? So the difference between normal queue and priority queue is something like this. So normal queue is something like the queue that you find in if you go to hospital, queue that you find in OPD, right? In OPD, what happens is the patients will be called according to their arrival, right? So the person who comes first will be called first, next guy, next guy, next guy. So that is why they give a number, right? So if you got number 40, you have to wait until the number 40 is called. So that is a normal queue. But priority queue is different. So priority queue means you are waiting in a queue, right? So if you are the last one to come, you have to go there, but it is not always first come first out, right? Right. So that means priority queue means it is priority out. So that means if maybe you are the last one who just joined, but if you are high priority, when next time when they call, maybe you will be picked. You will be picked. So that is what is known as priority queue. It is something. So normal queue is something like the queue in the OPD. Priority queue is something like the queue in the accident service, right? Accident service, because there you can't say that okay, you came late, there are some patients who came before you, therefore I am we are not going to attend you. Maybe these people have come with small wounds or whatever. This guy is in a critical situation, he just came. In that kind of situation, we have to attend to this guy rather than these people. So it's something like the priority queue is something like that. So it's always priority out. The highest priority guy will be taken out. Then the next highest priority guy as well. But new people, new things will be added to the queue as well. But then next time, all the things will be considered and take the highest priority one. Okay, right. So that is called priority queue. Now let's see how to implement the priority queue. Right. So there you have just one implementation called priority queue, right? Unlike the sets we have three, list we have three. No, priority queue we have just a priority queue. Of course, the linked list is a normal queue, right? Now let's see how to implement a priority queue. So let's save this as priority queue demo. Priority queue demo. Java, so that I don't have to save type again. Right, priority queue. So I'm going to delete these things. I'm just going to keep one system out. Now let's see how to create a priority queue. Right. So what we are going to do is we are going to create a priority queue object in this case, right? Because we because we don't have interface called priority queue, right? We need the priority queue nature. So because we are running out of time, I'm going to just copy paste to preserve time. Let's forget about this integer for the time being because we haven't done the generics yet. Right, so we have created a priority queue object, and I am keep on adding data now. It's now adding to the queue 10, 20, 15, right? Right. So now we have added data, same methods as the list and sets, right? Adding. Then I'm printing the queue. So when I print the queue, let's print it first. So I just added them. I have just added it and I have print the queue. If it's normal queue, it just with 10, 20, 15, right? 10, 20, 15 because the order of insertion is 10, 20, 15. Now let's compile and see what is the queue, how the queue looks like. Okay, cannot find symbol PQ. Yes, I think we have to go for because it's trying to find out the priority. We have to preserve the data type. Okay, so let's make it integer. I will explain why we put this line later when we are doing the generic. So okay, so for the time being, forget about this line or the meaning of this. So I am just restricting it to integers. We will discuss this when we are doing the generics. Okay. Right now, let's see whether we are going to be okay. That is wrong. Integer. We are getting that does not take parameters. So let's do a quick Google search because I can't figure out what the data is. Okay, Java.
Sir, can you check
Sorry.
the chat? Can you check the chat?
Okay. So you figure it out. So okay, class name should be changed to priority queue. Okay. Let's see. I made a mistake. No. Okay, priority. Okay, my class name is also priority queue, right? Yeah. So that might be the issue. Right. Let's make it demo. Yeah. So okay, so someone who has a lot of exposure can figure it out that issue, right? Figure it out that issue. That is a very tricky issue actually. Sometimes it's very difficult to catch that issue. Actually, if you didn't pick that issue, my Google search is never going to find me the issue because now can someone explain what was the issue, right? What was the issue? Actually, I know that he must be able to explain it. Can someone else explain it? What was the issue I was having? It's a very tricky error. Now you can see that, of course, he must be able to explain it. That is why he figure it out. So the reason is now I am using built-in class name with priority queue, right? So priority queue is a built-in Java class, right? Built-in Java class. When my class name is also priority queue, what will happen is my class has the preference over the built-in priority queue class. Okay, so I am expecting some functionalities from the priority queue class of the Java collection framework. But now, when my class is also priority queue, now my class has the higher priority, or my compiler is going to pick that. Okay, this is more higher. So all the functionalities must be taken from my class rather than the built-in class. So that is why that is why it's told that these integers are not found and those generics are not there, because obviously my class I have not specified those generics, so these methods etc. Okay, right. So that anyway, so I should thank him, because otherwise I am not going to pick it in a hurry. Okay, right. Now let's do it. So I just change it to different name, so that now my class name is different from the Java built-in class name. Okay, right. So let's compile it again. Now it is priority queue demo. Right, now you can see it's printed as 10, 20, 15. What is that order? That is the order that I entered the data. Right, entered the data. Now in priority queues we have different methods. Now remember, in other cases like sets and list, we had something called remove, add and remove. But in priority queues, it's different. We have two methods called peek and poll. Right? Peek and poll. So peek means we are just peeking. So when we say peek into something, just මූණ දාලා බලනවාට කියන්නේ. හරි මූණ දාලා බලනවා අපි පූණ ගන්නවා. So same thing. We are not removing anything. We are just checking what is in the top. What is in the top. Okay. Now let's see what is going to happen. Now you can see it's 10, 20, 15. That is what I entered at 10, 20 and 50. Now let's compile it again. Now you can see the order has been preserved. Now let's peek and see. Right, now you can see that when I peek it says 10. Right, when I peek it says 10. So obviously 10 is the one that I send first. Right, I send first. Now let's poll. Okay, so when I poll it again, you can see it is 10. Right, 10. Now let's poll it again. Right, so what you are expecting after 10? If it is a normal queue, after 10 because after 10 you expect 20, because after 10 came the 20. Now let's poll it again. So poll means taking out. Now 10 has been taken out. Right? Once this line is executed, 10 is no longer in your queue. Right? 10 is no longer in your queue. Now it is a normal queue, so the next one must be 20. Okay, next one must be 20. Right, but you can see this is for polling and the peak. Right, now you can see the next one is 15. So that is why we say it's a priority queue. Right, now you can see it is something like say this guy has had number 10, came to the clinic as the first person, then the second person came as had number 20, the third person came at number 15. Though he came third, he is more priority than this guy, because he has a lesser number. So therefore, obviously, first 10 came, then came 15. Though he came last, the second one is coming out is 15. So that is why we say it's a priority queue. So the only next time only 20 is going to come out. Right? 20 is going to come out. So the way you define the priority in this case is by default when it comes to integers, the smaller number has higher priority. So that always you can override by overriding certain methods in the priority queue class. So that is where the object oriented concepts comes. So if you want your priority queue to behave differently, that means you want the bigger number first, right? Then you can override. You can go through the Java API of the priority queue method and see how can you do that. Actually, that's a very good exercise. Can you so take it as sort of exercise? if I want to have my priority queue behave such that it takes the bigger number first, then the next bigger number, what you are supposed to do, because the default behavior is for integers, priority queue, the default behavior is smaller number has the higher priority, right? Now, so take it as sort of a exercise for you guys, okay? Right, so that you can apply your knowledge on object orientation. Right, now we are done with the priority queues as well, right? So just you can see that we have the peak method. It will not remove it, but it will check who is going to be the next. But the poll method is the guy who is going to remove it as well, so that the next priority one guy will be the next poll candidate. Okay, right. So now we are done with that also. Now we are moving to the final collection framework called final collection. That is map. So map is a little bit different from other three that we discuss, right? So that is why map is not directly extended from the collection interface. Now you can see these guys are all coming from the collection interface, but map is, all these maps are from different interface. So it is not actually extended from the collection interface because they are little bit different with data structure. So we have a map interface, right? So then implementing the map interface, we have the hash table, hash map, link hash map, and tree map. Of course, tree map is indirectly implementing the map because we have the sorted map and navigable map here. So you don't have to worry too much about that. So, but you have to remember is we have an interface called map, then we have few implementations, right? Actually, there are 4 implementations, but we are more interested about the hash table, hash map, and tree map because link hash map is a special case of hash map. Okay, right. So let's first try to understand what is mean by map. Okay, what is mean by map in Java? Right. So as I told you, this is somewhat different data structure. So when it comes to map, it is a key value pair, right? Key value pair. So key value pair means uh, it has something called key, something called map value, right? Key and value. So as I told you, maybe Nimal 50. Kapila 70, maybe Colombo 27, Nuvarelia 16, maybe temperature. So your key, you now you can say, but if you want to find the temperature of Nuvarelia, you can say your map and you have to provide the key Nuvarelia, then it is going to tell you okay it is 70. Right? So that is also very useful in certain situations. Okay, right. So when it comes to map, you have to give two things, right? Two things, that is your key and the value, right? Key and the value, those two things you have to give. Here you don't have something called add, rather what we have is put, right? Put and get, put and get. Now let's do a small code and try to understand that. So I will save this as map demo.java. First of all, I am going to change the name because last time I had issue. So as long as I have the name demo, that is fine because I'm going to use the map. So let's keep just once. So I'm going to use here the interface and here the implementation hash map. Okay. So there you have to tell what is the type of uh, key, what is the type of value, but that is optional. So that let's create something like this for the time being without. So this is called generics. Let's forget about generics for the time being. Okay. So now you can, this is one of the implementation. This is the interface. Okay. So let's call it M. Right. Now let's try to put something because we don't have add here. M dot put. m dot put. So we have provided two things, key and value. So let's say Nimal 50. Let's say Amal 80. Let's add one more. Let's say Asmi 70. Right? Now let's see. Let's get it. So how to get it? My map reference variable is m, put and get. There you have to give the key. Let's say Amal. So it must ideally return you 80 because the value for the key called the key Amal is value is 80. And now let's compile and run it first. I hope this will work. I am not sure whether we need to give the data type. I hope no. So let's compile it. Let's compile everything. No error. Java M. I'm just typing tab, right? So that it will pick the file name. Right now it says 80, right? So because Amal, the key Amal has the value 80. So it can be anything actually. So here you might have numbers and here name, right? So likewise there is a lot of flexibility, a lot of flexibility. Okay. So you can see it's a different thing. It is now you have something called key to play around. So we never had something like that in list and map and of course priority queue. Right? So now it's just you can put it's something like what happens when you go to a shop, right? When you go to a shop, so if you are taking any bags or whatever, you have to keep those bags, right? You have to keep those bags there because bags are not allowed inside the shop. If it is something like a textile shop or whatever, then what will happen? They will keep your bag and they will give you the token, right? So now you go and when you are done with your shopping, you come back. Then you give the shopping. So then you give you the your token so that they will give you the item. Right? So your token is your key, right? Your belongings, so what your bags is your data, right? So when you are inserting, you are giving the key. When you are asking for it, you have to give the same key so that you will get the same data, right? So something like that. You can see it's a very practical scenario. Very practically, we heavily use maps, right? Heavily we use maps to get the data, especially when you are doing the database programming, right? What will happen is your database is going to send you the result in your SQL, then it is going to put it into a map with key values as your field name, the database table's field name, and the data as the data, so that you can give the field name and get the data. Right? So you will do that kind of programming when it comes to PHP that you will be doing in your web development 2 subject, right? Right. And also we are going to do a little bit of JDBC if we have enough time, right? Okay. Now I hope you got the idea about the hash map. Then again there are different implementations of hash map, right? So we have the hash map, hash table, link hash map, tree map, right? So for this kind of things, it doesn't matter which one you are using. It's going to behave the same way. I just changed tree map now rather than hash map. I am going to get the same answer. So same answer because all are maps. Again, there are small differences between these. Okay, between these. So now you must be able to figure out what are the changes. So now you can see if you see something called hash, that means it is unnoded. Unnoded, right? When you see hash, unnoded, right? So then the difference between hash map and hash table is this guy is not thread safe but faster, This guy is thread safe, that means synchronized but slower, right? Slower. Then when you say link, it means what? It preserves the insertion order. Now you can see you don't have to memorize once you understand these patterns. Whenever you see link, that means insertion order is preserved. Whenever you see tree, it is sorted. Right? So it is sorted. So same thing, right? Same thing as your the sets. Remember the tree set sorted. Linked set link has set is insertion order is preserved, but hash set was unordered. Same thing, hash map, but only difference between these two is all about the thread safety. Then we have the ordered one, sorted one. So these are the unordered one. So here the thread safety issue is there. Okay, right. So likewise, once you understand the pattern, it's just a simple concept. Okay, but of course, if you don't understand and if you try to memorize these things, after sometimes you are going to be sort of ended up as a sort of a crazy person. Okay, so that is why we say education must be either you do it properly or you don't do it, because it's going to be a headache for you after sometimes. Okay, if you are not doing it properly, right? So that's it. Now let's see how to iterate, because what we have done so far is put in something, take in something, and of course we can check whether something is there, how many elements are there, right? So sometimes what we want to do is, once you insert your data to a list or set or whatever, sometimes we want to take one by one, or you want to search one by one. So that is where you want to do iterations, right? So in arrays, remember we had two options: the normal for loop with the index you can iterate, or we had something called array friendly for loop. Using that also we were able to iterate. But in array friendly for loop, it's always from beginning to the end. But normal for loop, you can go from anywhere to anywhere, or even in reverse order, right? So likewise, for collection frameworks, also we have two approaches. That is, just like your array friendly for loop, we also the same for loop can be used for collections as well, right? Just like your array friendly for loop was used, you can use the same for loop for collections as well. Then we have another concept called the concept called iterator, right? If you want little bit more flexibility, you go for concept called iterator. But if you just want to iterate from beginning to the end, you can go for this the collection friendly for loop, which is same as the array friendly for loop. Okay, right. So let's first look at the array friendly for loop. Okay, array friendly for loop means array friendly for loop and the collection friendly for loop is the same. Okay, right. So let's take our list demo again, because we had a list there, and let's iterate it. Okay, let's iterate it because we had data. So by the time some of the data is not there, because I have removed some data, right? Of course, 1, 2, 2 is not there. Now it will be 1, 3, and 1. 1, 3, and 1. So let's use a loop. It's very easy. 4, 4. Let's say our array is L1. So you have to use the data type, remember? So if you are, so that's something I want to explain. When you add something to a list or any collection, if you have not specified the data type using generics that we are going to discuss later, if you haven't specified if you haven't used the generics, they always think that it's object, and they always think that it's object. Okay, so therefore when it is written, what you get is object, right? You may have inserted a string, you may have inserted a account, or you may have inserted a dog, but what you get is object, right? What you get is object. So that is something you have to understand. Of course, it's a if you are really interested, you can read the head first Java book, right? So there it explains in a very nice manner why what is the meaning of that. I am not going to explain it right now because it will take another half an hour. Okay, using the object-oriented concept, polymorphism, etc. Okay, but you must be able to understand that if you, because we have done the all the polymorphism and inheritance, all those concepts sort of up to the required depth. But if you read the head first Java book, you will understand why when we are inserting string, why we are getting object. When we are inserting a dog to the list, why I am getting not a dog, rather object, right? So actually there are there's so the head first Java book, it explain it using a nice story as well, right? Because it is full of stories. Okay, that book is full of stories. Anyway, so if you are curious, just go through the head first Java book or any other YouTube tutorial and try to figure it out. Okay, right? Anyway, so what you get is, now though I have been adding string, what I am getting is object. Okay, what I am getting is object, therefore the type must be object, right? So remember, for the variable we have to give it a name, so let's for the time we call it O, then colon our collection. In this case our collection is a list, L1, L1. Okay, so this is the same way we did the iteration of the arrays as well. Okay, but only thing is, in arrays we have always specified the data type, therefore it will be something like int, double, or whatever. But here it is always object if you are not using generics. Of course you are not using generics yet. Right, now we can print it. We can print it. So let's see, say O, because anyway object can be printed because it will be converted to the string implicitly, right? And printed. Okay, so therefore now let's compile our let's run our list demo again. So I'm going to compile everything. Right, now I'm going to run Java list demo. Now let's see whether it get iterated. Now you can see 1 3 1. So let's better put some system out printed to see whether the iteration starts. Right, now you can see 1 3 1 because the 2 was removed. It is 1 3 1. Now we managed to iterate it one by one. Of course you could do anything with your object, right? I just print it. So that is the first way of iteration. So same thing can be done for sets as well. So let's take the set demo. So that one also I can iterate same way. In that case, the set first called S1, S1. So let's iterate. Right. So it says 1 and 3 because ultimately it is 1 and 3 is there because 1 was removed. So we can use the iteration, but for map you can't use this approach, right? This for loop is not going to work for maps. For that you need somewhat different approach, but it's going to work for list, set, and even priority queues. Okay, right? So that is the first approach of iterations. The second approach is the use of iterator, right? Iterator. So we have a concept called iterator. Using that also we can iterate. So I will just copy this and paste it because I want to do it a little bit faster. So I'm going back to the list interface or the list demo. Now I'm going to use this concept called iterator. Okay, so let's have another thing like this here. Right, so this is how you do that. We have another class, in built-in class in Java called list iterator, right? So from your list, so in my case L1, there's a method called list iterator method. So when you call that method, it is going to give you the iterator for that particular list. So in my case, I am getting the iterator from my list one. So it is going to give me the iterator. So iterator is a helper class, so helper object that you can use to iterate or go one by one, visit one by one. So then the list that iterator object has a method, two import methods called has next and next. So has next method will be returned true if there is another method to iterate or move forward. It will give you false when there is no more object to visit, right? So therefore it will keep on true while there is some more data to traverse, but when you at the end this will be false, therefore you will go out of the while loop. Then the next method is the one that is going to go to the next level and give you the next object. So I am now getting the object and printing it, and also it is moving to the next guy, right? So it's something like this. So when you have this kind of data, initially the iterator will be here. When you say has next, it will say yes. When I'm calling next, right? Actually initially it is somewhere here, right? When it say has next, it will say yes. When I call next, it will come here, and now I'm printing this. Right? Next time when I ask has next, it will say yes. When I say next, it will go there, it will be printed. Now next time this next time this, when there is nothing here, when I ask has next, it will say no, you will get out of the loop. Okay, so you can see it's little bit more work, little bit more work than this simple for loop, but this one is more versatile. Right? The hash next is just one method. There are some other methods you can go forward, backward, etc. Okay, right. So therefore, this is another way of iterating. Right, this is another way of iterating. So let's compile and run it. Right, so second one came from the. No, I didn't get two iterations, right? So why not? Okay, I haven't saved it. Let's compile and run it again. Right, so this is from our for loop, this is from our iterator loop. Okay, iterator loop. So if you don't know the iterator loop, you are never going to do some database programming, etc. Because there, once you get your data from the database for your select query, you are going to use your iterator to navigate it in different way and print it into the user the to your web page or whatever. Okay, so therefore without understanding these concepts, of course you can pass your first year. So that actually that is a terrible thing, that is some that can happen to you, that is you pass your first year and you stuck in your second year or third year, right? So that is sort of a very uh, right, අපි කියන හතුරෙක්ටවත් එහෙම වෙන්න එපා කියලා. එහෙම වෙන්නවා මේවා තේරුම් ගත්තේ නැත්නම්. හරි? Right. And of course, you have to always remember it's about 250 people who is getting the degree. So I want to be one of them, right? It doesn't mean that BIT is more difficult than any other degree. No, not at all, right? So it's just the same standard as is NSBM or strict or whatever, right? Or right. So you have to be as serious as these people, okay, or at least a little bit more serious than these people, okay, right? So same similarly, you can use the iterator for set as well, right? So I just explained you for the list. So same can be used for set as well, but for uh, maps you have a little bit more work to do, right? You have a little bit more work to do when it comes to maps, right? So that is also you have to understand. Anyway, we will discuss that when we do the generics, because without having generics, working with iterate is little bit more work for maps. Okay, now we are done with collection framework. Actually, we haven't done everything. What we have done is a gentle introduction into collection framework so that you can self-learn when you are doing in real world software development. Okay, so just enough confidence is given to you so that you can start your real world work with your programming language. Okay, so don't expect that this is everything, but now you got to about 75% of the content, and almost the big picture is with you. Okay, right, now we are moving to our second topic for today. So the second topic is not the big one, so the big one is done now. So the second topic is generics, right? Generics in Java. So I mentioned this word few times when I was doing the correction, but I just kept talking that okay, we will encounter this later. Now we are going to face this. Okay, so generics is a new concept actually, came somewhat later, about 10 years back, right? Not it has not been there from the beginning of the Java. It came for a specific purpose. Actually, this concept of generic was is not in all the most of the other languages. It is Java that is heavily promoting this concept for generics. In a lot of other languages like of course Python, PHP, you hardly find this concept for generics. And of course, I haven't done any very advanced programming using Python. I never know whether that concept is there, but it looks like it is not there. Anyway, Python you can't have very serious generics because it's a weakly typed language, right? So, but even languages like C, C++, this concept was not there, right? So this concept was basically introduced by the Java people. Okay, now let's see what is meant by the generics. So you will find it little bit confusing at the beginning because this is little bit advanced concept unless you have done some software development and of course at least some programming by your own, not running whatever the code that others are giving you. No, you think of a problem and you try to solve the problem. So that is what is known as software development, right? So then you will find this little bit easier, but otherwise you will find it little bit complicated subject. Okay. Anyway, let's try to figure it out what is mean by generics. Okay. So so the conceptual generic is there to introduce better type safety for your objects, right? Better type safety because we know that type safety is a really good thing. So type safety means when we have a particular requirement, say if you are expecting strings only, if another data is accepted, it's not a good thing, right? Then runtime you are going to have troubles, but at compile time, if you can pick those issues, then we say we have better type safety, right? Better type safety. Now you have seen that in the especially when we were doing the list, I deliberately, okay, I didn't explain you that particular thing, but now I am going to explain it, right? Now here, I am not saying whether this my array list is a string array list or Java array list, sorry, or int array list or double array list or whatever. I am just saying it's array list, okay? So therefore, actually, I can insert anything here, which is not that good thing, okay? So I will demonstrate that. So let's take so I'm going to create another folder here, generics, because it's a different topic. Generics. So I'm just going to copy one of the class from here, preferably the list class. Right. So we'll call it still the list demo, or we'll call it list generics demo. And this is applicable for not only for list, it is applicable for map, it is applicable for set, etc. But I'm going to explain it only for list for the time being. Okay. So let's call it list generic demo. Okay. And so now these things I am not interested. These things we have already explained. Some features of this. Right now you can see that I am adding. So let's go for only 1, 2, 3, and 3 only. So I am not interested in size as well. For the time being, I am keeping these things. So I just add three data and maybe I just want to print it. My L1. So let's compile and run it. This is called list generic demo. Now I have to move to the other folder. cd dot generics, right? Java C star dot Java. Right? It has been compiled. Right? You can see the class. Now let's run it. Java. Now it's print 1, 2, 3. That is same as our previous example, right? Now, because I am not specifying the data type here, this is not type safe. This is not type safe. For example, I can add something like this. So I can add something like 5 or 6. So I can add something like 2. So basically, you can add anything. You can add anything. Right? You can add anything here. Uh, anything is accepted. Anything is accepted. Okay, see, I am adding strings, I am adding integers, I am adding boolean, right? So anything is accepted. But in software development, this is not. Of course, there are situations this is okay, but usually that is really dangerous thing, right? So allowing anything to be added to your collection, right? So in this kind of situation, there is no thread safety. There is no thread. Sorry, there is no type safety. There is no type safety here. If you want to go for type safety, you can use generics now, right? So what you have to do is you have to say something like this. If I want to add only strings, I will say string here and string here, and here also I am going to say string. I hope these things will not be implicitly casted, right? I hope. I will see. Now I am saying I am only expecting strings to this add method, but this is not a string, this is not a string. Of course, these are strings, those are fine. Earlier, anything was allowed. Now let's compile and run. Now you can see compile error. That is what we expected. Remember we discussed in error handling, there is something called compile time error, runtime error. If we can detect most of the errors at compile time, that is really good. So that is what we expect, right? So then, because runtime errors sometimes we may miss. Sometimes it might go to the production as well without detecting. So we want to detect those issues fast. So now you can see it says, because now it is we are using generics. Now we are saying that it is not just list, it must be type of string or string list. Same class, same class. Now later I can create another list, right? Another list saying it's an int list or double list. Let's say integer list. Now only integers will be allowed, nothing else. Right? So let's say 5. Delete this. Let's call it L2. Now this is fine because I am saying integer and those are integers. Now here integer is not allowed because I am saying string. But now here I am saying integer. Therefore, I must be fine. So let's compile and run it again. Now I must not get any errors because I removed. Okay, I have to remove these things. Otherwise, I will be getting the errors again. Now this is fine. I'm saying string and those are string. This is integer. I'm saying those are integers. Okay.
right? Now the type safety is there. Type safety is there. Again, if I try to insert a string here, I am going to get a compile time error. That is really good. Detecting issues at a compile time. So let's say hello, because now it says it's an integer list. Right? You can see it says no suitable method found for add string. So it says no, it is not for string. You are trying to add a string, but here it is for string. Yes, you are fine. Right? So now this is not allowed. So if when we are using like this, we say we are using the concept called generics, right? So in the collection frameworks, it is always preferred to go for this kind of generics. Of course, we violated that all the time, right? When we are using the list, when we are using the set, when we are using the map, right? Everywhere we never go for the generics. But that is why we will keep on getting this now I'm going to recompile it. So I will save it. I remember when we were doing compiling some classes, if I just change this to somewhere here, I'm just removing this. Now still I am not going to get any compile errors. Now I am not restricting it to string, but I am only adding string. That is fine. But compile time, if I add integer, now it's not going to be detected. But now I am going to get a compile time warning. Now here you can see no warning. Now you can see that now it says that there are some warning sayings you are doing some unsafe operations. Yes, I am doing unsafe operations. I am not specifying the data type. Therefore, someone might insert some even dog to here, right? Even account object, right? So the best practice is whenever you collections try to use this generics and make sure that you are making it type safe. Okay, you are restricting it for a particular type, right? So that is very important when it comes to a professional business level software development. I hope you want to be a professional software developer, business software developer, who want to go and work with your fellow software engineers. Of course, otherwise you don't worry about these things, right? So you can you get your degree and do whatever you want, some other task. Okay, right. Right. So now that is the idea behind generics, right? Even for maps, right, or sets, especially for maps, you can use the generics. In that case, let's create a map here. And so rather than call this list generic demo, I will call it collection generic demo. So I'm going to create a set here, map here. Say map m equal new hash map. Now if you create this is again not type safe. Not type safe. I can add anything to the key, I can add anything to the value. But if I want to make it type safe, I have to say something like this. So what is the data type for the key? What is the data type for the value? I will say integer and string, or maybe string and integer. Even it can be string and string depending on your requirements. So here you have to define it after the class name. You have defined both the time, both the places. You can't just have it only once. No, it's not going to work. Okay. Right now, if you want to put something, m dot put. Now first one must be string, second one must be integer, otherwise you are going to get compilers. Colombo, let's say 28. Can be 24. Even you can use the space here because anyway I will just not use space. Say 19. Now this is going to work again and let's print it. And save, compile and run. System out. Semicolon. Yeah, here. Now I must be able to run it. Now it's no longer list. Right? It's a collection generics demo. What is that? Should I say Java? Okay. Java collection generics demo dot class. Right? So these are the values. Colombo 28, Nuvarelia 19, Candy 24. But now I can't do something like this. I can't say Nuvarelia is hello. That could have been done previously when we were not using generics. Now I'm going to get a compiler. So now I'm going to get now you can see the type safety is there. So type safety is a really good thing when you are developing a serious software, right? Serious software, robust software, because you don't want to take any chance, especially if you are developing a framework or something, so that others also going to extend your code. Right. So that is the basic idea behind generics. So this concept called generics can be further extended, so that what you have seen is use of generics used in the collection framework, like use of generics in the collection frameworks. So this idea can be uh, extended to other areas as well, right? Other areas as well, or you can use it as a general concept to make your own. Especially if you are developing a framework or something, you can use that concept. Okay, it's a little bit advanced concept, right? But once in a while they ask these kind of questions as well. Actually, I just double checked the past papers and I found that one of the last 3 4 years they have asked one question from generics. Okay, so therefore I'm just quickly going through that one also, because there are people who want to be little bit serious in their software development, right? So now let's see how to make our own generic classes and use this is now we are using the concept called generics, which is built into the collection framework, right? So but when you are designing our software, if you are designing our own frameworks or something, especially if you are designing your own framework, right? Now still you are using others framework, but you never know, after sometimes you might feel like, okay, I want to develop a framework for our business organization, our software company, our company. We have to do that kind of things, right? So when you are getting senior post, you involved in developing your own frameworks, etc. as well, right? So in that kind of situation, generics are going to be really handy. Okay, so let's see how to create a use something like that. Okay, right. So this is an example of. So I will explain a class a full example. So I will just copy paste. So rather than copy paste from here, I will be copy pasting it from my Word document, because otherwise I have to keep my all my line breaks are going to be vanish. So generics is 19. I will be posting the code, today's code, to the WhatsApp just after the session. This PDF I am going to upload after the session to the Google Classroom. Okay, so after about 10 minutes or 10-15 minutes time, it will be available in the Google Classroom, right? So the generics, collection framework, and also input output. It will take about a half an hour before I sleep, and definitely I'm going to upload. Okay, because I have to do a little bit flattening. Right, so I'm just going to copy paste this so that I don't want to type everything. I just want to explain you the concept called generics, how to use it. Okay. So this class name is called entry. I'm going to create a file called entry here. Right, not collections, generics. This is a very interesting concept actually. If you want to do some advanced things, not the hello world kind of a mindset for people. So I'm just going to paste this class called entry. So let's compile everything, because this will also be compiled. No errors. My class was compiled. Entry class. I will explain what is mean by how entry class a little bit later. Now let's create the test class as well. So I will call it test entry. This is not actually a very difficult concept, right? If you are really good in your object-oriented concepts, so you have to spend some time and understand. Okay, right? So let's create a class test entry, and let's create a main method, public static void main string args. Right, so I'm just going to paste this. Right, now I will explain the code before running. Right, so now what we did is we created a class called entry, and we created a class called entry, right? So there I have two variables. Actually those are sort of a constants, because they are made final, called the key and value. Key and value. Now you can see usually when you are creating classes you don't have something like this, but here we have specify something like this. Here you can give anything, even you can just say x and y, right? X and y, but for little bit for description purpose I have just make it key type and value type. So that means when you are creating an entry class, right? Sorry, not we are creating entry class. When you are creating object of entry class, you have to give me the data type that you are going to work with this entry class, right? Just like, right? Just like when you work with, right? When you work with this map, you are specifying I am going to use a string and integer for this map. So my key will be string, my value will be integer. Right? Just like here, when you are creating a list, you are saying, okay, I am going to use an integer with this list. I am going to use a string with this link. So same similar concept. Here, when you are creating an entry object, you have to give me what are the two data types classes that you are going to work with this entry, right? So those two are going to be two instance variables, and also you can see that now rather than now usually this if it is a variable here you must have a data type or at least a class, but now you are using your key these things as your classes, right? These things as that means your key is of type key type, value is of type value type. So at the runtime, you have to tell me what is the key type, what is the value type, right? So if you say you create an entry with now here you can see you are creating an entry and you are saying string and string. So that means for that entry object, your key type is string, your value type is string, right? So here you are saying string and integer. That means your first one is string, second one is integer. That means your key is of type integer because key type is integer, your value is of type in string, right? So likewise now it's up to you to decide what are these types are. Now you can see these data types are now not hard coded. I am allowing the user of the entry class or the person who is going to create the object of entry class to decide what are these data types are. Now you can see this is heavily general scenario. That is why we call it generics, right? My class is extremely general now, right? Extremely general. Even the data type of my variables are also decided by you, right? Decided by you, not by anyone else. Okay, not by anyone else, right? Right. So that is why you are able to create these kind of things. Now, when you are creating a string, now for this grade one, you have to give uh, two strings, right? Two strings. So that is why we are giving it as Mike and A. So here when you say string and integer, you have to give string and integer, right? String and integer. You can't give a string here because you are saying that your second one is integer. Okay, second one is integer. So that is why you can compile it. Now let's run it. Java test entry. Okay, so I haven't compiled it yet. So let's compile it again. Now you can see. Now if I here add a value like this, here if I try to insert a string, I am going to be in trouble because it's going to be checked at the compile time. Let's say hello, it's not going to work because I am saying second one is integer, right? So you can see compile time error. So that is the beauty of generics. Just like when you are using collection framework, when you say string, when you insert int, you got the compiler, you got the compiler. Same thing is there, right? Same thing is there, right? So therefore I can't do like that. So actually what I have implemented here is basically the basic structure of the map implementation. So actually the Java people have implemented the map using this kind of a structure, right? So if you just forget about this and if you just look at this, you will see that this is just a map. I am just calling it entry, right? I am just calling it entry. This is just a map, right? That you are creating, right? You are creating, okay? Right. So I'm not going to details. There are a few more concepts related to generics, but this is good enough. This is good enough for you, right? For you. Okay. Let's see whether we have any past paper questions that we can do. Okay.
maybe very few, but in the future we expect more. Right? In the future we expect more from collections and especially generics. Now let's see whether we have any generics related questions. So I may miss few of those. So this is input output. You can hear me, right? Because it's raining. Sometimes my internet. Yeah, I hope you can hear me. Okay. So let's see whether we have any questions from there. What we have done so far. Of course, there are more questions from the input output. So this one we did last time, enumerations. Annotation question. And strings we did. Right, so this is from collection framework, very simple question. Select from among the following valid interfaces in the collection framework which must contain unique elements in it. Now you can see two portions are there. It must be a interface, not a class, and it must contain only unique elements. That means what? Set interface. Right? Set interface. Of course, list collection are also interfaces, but you can have duplicated. There is no such thing that the unique elements must be there when it comes to list. And of course, collection is a more abstract interface. These are not nothing to do with the collection framework. So integer is just a wrapper class. Array is a class of an array object. Okay. Right, so this is another question from Java collection framework. You can see they ask only very simple questions. So that is why I told you that I am not interested in the exam. I am more interested about your progress, right? And your whether you can go and work with other fellow software engineers. Select from among the following valid options which are not interfaces in Java collection framework. So same question repeated, right? Same question repeated. I am not going to do it again. Now this time they ask what are the not interfaces, right? Not interfaces, right? So of course list is interface, map is interface, set is interface, collection is interface. There is nothing called group. The answer is D. Okay, answer is D. Right. So this is a generic question. This is a generic question. I think this is the only generic question I found in last 4 years. Consider the following program written in Java. Public final class exercise 44. Now here you can see in the class they don't have generic, but in the method they have generic. So there's a public static method called T. There is a type here, right? In the method name is max, and that the first variable must be of that type. Second variable must also be of that type. So that means if someone is sending, right, actually if you have something like here, the class declaration also must have the T, otherwise you can't do that. That is a different issue. But anyway, so it says that these two variables must have the same data type, and your output must also be the same data type. If someone says it is int, all of a sudden this method is going to be int right? Int method name is max, and you need to send two int parameters, uh, int x and int y, right? So that is going to be your method signature. If it is you are saying string, this is string, this is string, this is string, up to you to decide what is going to happen, right? So therefore this is going to check your type safety, because it is using it is going to check whether you are giving to giving same data type here, okay. Now let's look at the answers. And then this is, you know, that this is the short circuited version of the if else, right? If x is greater than y, uh, it will return x, otherwise it will return y, okay. So that is something to do with the if else. Now what is the question? When the program is compiled, there were errors generated. Select from among the following the valid options which cause the generation of those errors, right? Of those errors. uh, so final class, of course you can make class as final, so that is okay, but that is not a very good thing to do. But if you have really security concerns or whatever, you can make it final. So therefore that is nothing to do with error. A public static t, no, you can have something like that, right? You can have something like that, but the error might be related to that, right? Because here you are saying t, maybe you are not using the same concept. So right, so maybe this is also possibility why when you are doing this operation only you are getting that error, right? But uh, the real reason must be the type safety, right? So the one of the possibility of actual not compile errors from this class, a class where you are using this, right? Class where you are using this, just like we got this particular compile error previously, right? So when I say string integer, if someone's try to send both string, it's going to be compile error. So that is type safety. So it can happen because this method signature is also like that, right? So therefore my answer is type safety, right? Type safety. So that might be the possibility of giving you the compile error. I think that must be the answer. 44. Yeah, not only C, they have take one more answer, C and E. But let's see why E is also taken as answer. So C is basically, okay, E is the type safety. They have taken C also. C also. So I'm not sure why they have taken C also as answer. Maybe, but type safety is answer. Sorry, E is okay, but they take C also as answer. I don't know why. Return x greater than y. So I'm not sure why they are taking C as answer, but yes, E is answer. I'm not sure, right? So I will double check and let you know if I found a reason. Okay. Let's see whether there are any other questions on generics and collections. Looks no. Exception handling. Yeah, no. There is input output. Right. So yeah. So IO streams, it won't take much time, but I want to do some coding with you, right? So therefore, I prefer to take this as a separate class because now it is almost 10:30. I may not be able to finish this if I start, because it will take at least 45 minutes more, right? At least 1 hour. So what we'll do is we'll take input output streams and maybe another topic like thread programming separately. Okay, so because thread programming is a somewhat smaller topic, we can take those two together and do it. Then we just have to do the swing programming and Java FX programming. Then our syllabus is going to be over. Okay, right. So we'll stop at this point. And we will do the input output stream and thread programming together in a separate topic, a separate session. Okay, right. So if you have any questions, you can just post it to the WhatsApp group. I will be uploading these PDFs and also coding. PDF I will be uploading to the Google Classroom. Coding I will be post to the your WhatsApp group. Okay, right. So we'll stop at this point then. Okay, right. Thank you.